Today we will be discussing with you some of the important MCQs relating to the chapter electricity. These questions will be very useful for examinations. So let's get started. We will go to the first MCQ. We'll go to the first MCQ. Our first MCQ is our first MCQ is 1 microcoulomb is equals to number A 10 to the power minus 6 coulomb, number B 10 to the power minus 7 coulomb, C 10 to the power minus 8 coulomb, D 10 to the power 6 coulomb. So what will be the correct answer? The correct answer will be 1 microcoulomb is equals to 10 to the power minus 6 coulomb. 1 microcoulomb will be equal to 10 to the power minus 6 coulomb. So we'll go to next question. Our next question is the unit of resistance is A ohm, B farad, C coulomb, D ampere. So what will be the correct answer, students? The correct answer will be the unit of resistance is ohm. So let's proceed with the next question. Our next question is 1 microfarad is equals to 10 to the power minus 12 farad, number B 10 to the power minus 6 farad, number C 10 to the power minus 4 farad, number D 10 to the power minus 2 farad. So the correct answer will be 1 microfarad is equals to 10 to the power minus 6 farad. Let's move with the next question. The next question is the unit of charge is. The unit of charge is, options are given, coulomb, B ohm, C volt, D farad. We all know the unit of charge is what? The unit of charge is coulomb. Let's proceed with the next question. The next question is what? Electric field intensity is sometimes scalar, sometimes vector. Number B, a vector quantity. Number C, a scalar quantity. Number D, neither scalar nor vector. So we all know that electric field intensity is the strength of an electric field at a given point and is calculated by dividing the electric force by the charge. Since force is a vector quantity and charge is a scalar quantity, the result of the division will always be a vector quantity. So electric field intensity will always be a vector quantity. Okay, so the correct answer will be what? Electric field intensity is a vector quantity. So we'll proceed with the next question. The next question is what? The instrument used to detect current in an electric circuit is. So the question is the instrument which is used to detect electric current. So mind it, dear students, here the question is given the instrument used to detect, okay, not to measure. The instrument used to detect current in a circuit is. Options are given: ammeter, voltmeter, ampere, galvanometer. We all know that what will be the correct answer? Before discussing the correct answer, let us point out the wrong answers. Voltmeter is used to measure voltage difference. Ampere is a unit of current. Galvanometer, and regarding ammeter is used to what? Read current. Okay, so if we are detecting current, here the question is the instrument used to detect current. The correct option will be what? The correct option will be the instrument used to detect current in a circuit. The correct answer will be galvanometer. Okay, rest three are not correct answers. So we'll move with the next question. The next question is which of the following is a conductor? Number A, ebonite. Number B, graphite. Number C, glass. Number D, distilled water. So here the question is which of the following is a conductor? We all know what is a conductor, is not it? Conductor conducts electricity, heat. So conductor is one. So from this options from these options from options A, B, C, and D. This particular distilled water and glass, this will not be correct. Okay, this will not be correct because glass and distilled water, we all know it is not a good conductor. And now the options are left what? Options are left with ebonite and graphite. So what is ebonite? Ebonite is actually what? Ebonite is a blackish brown. Ebonite is blackish brown in color and formed by mixing and heating sulfur and rubber together. Hence, ebonite is not a metal and does not have free electrons to carry current. We all know that in order to carry current, we need free electrons. That's why ebonite is not a good conductor of electricity. On the other hand, what is graphite? On the other hand, if we point out to graphite, then graphite is what? Graphite is a good conductor of electricity because of its structure. The carbon atoms in graphite are arranged in hexagonal pattern with each carbon atom bonded to 3 others in the same plane. The last electron bonded to carbon atom is always free and is moving. So this electron carries what? This electron carries current. So what will be the correct answer? The correct answer will be what? The correct answer will be graphite. Ebonite will also not be the right answer. Okay. So we'll proceed with the next question. The next question is what? Which of the following metals has lowest resistivity? Options are aluminium, B, silver, C, iron, D, copper. So as compared to silver, we all know what is resistivity. First out, let us find out what is resistivity. Resistivity is what? Resistivity is a characteristic property of the metal itself. It is defined as the electric resistance of a conductor of unit cross-sectional area and unit length. It's a characteristic property of each material and is represented by the symbol what? It is represented by the symbol what? Rho. Okay. So resistivity is represented by the symbol Rho. Now you see here that aluminium, iron and copper. Okay, aluminium, iron and copper, these three materials have less resistivity. Okay, these three materials are more resistivity as compared to silver. Silver, among the options, silver has the lowest resistivity. Okay, the correct answer will be what? The correct answer will be silver. So we'll proceed with the next question. The next question is what? The next question is, in a domestic wiring, the various distributions are connected in series connection, parallel connection, both series and parallel, and number D, none of the above. So domestic wiring is what? In a household wiring. Okay, domestic wiring, the various distribution circuits are connected in. Options are given here. So we all know that in domestic wiring, the various distribution circuits are connected in parallel. It is because parallel circuits have a number of advantages over series, is not it? What are the advantages? That if we connect in parallel, constant voltage supply is there. Each circuit has same potential difference as the supply line, so each appliance works at constant voltage. So if one circuit is overloaded, only the fuse in that circuit will blow, leaving the other circuit safe. So in domestic wiring, the various distribution circuits are always connected in parallel. The correct option will be what? Correct option will be parallel connection. Okay, the correct option will be what? Parallel connection. Okay, the correct option will be what? Sorry. The correct option will be what? Parallel connection. So next we will move on to next question. Next question is what? Good conductors have many loosely bound neutron, protons, electrons and atoms. So what will be the correct answer, dear students? The correct answer will be what? We all know good conductors have many loosely bound what? Electrons. These electrons are called what? Free electrons. Good conductors allow electricity to pass through them because of their loosely bound electrons. Okay, so what will be the correct answer? Good conductors have many loosely bound electrons. The correct answer will be electrons. We'll proceed to next question. The next question is what? The next question is, the fixed resistance is called dash. Options are given: switch, resistor, rheostat, key. In an electric circuit, we all know the definition of switch, key, is not it? So switch is what? Switch is a means by which this electric circuit is closed, so this will not be the correct answer. Key is what? Key is also key is included in switch, so when the key is closed, the circuit is closed, so this will also not be the correct answer. The fixed resistance is called dash. We all know about rheostat, is not it? What is a rheostat? Rheostat is a variable resistor that lets you manually control the flow of electric current by changing its resistance. It's used in many appliances that require adjusting the current or resistance in electric circuit. So it is a variable resistor, okay? So it does not have a fixed resistance. Its resistance can vary because it is a variable resistor. It's a device with which it can vary your resistor. So this will also not be the correct answer. The fixed resistance is what? The fixed resistance is your resistor. Why resistor? It is because a fixed resistance is always called a resistor. A resistor is a component that has a constant resistance value that cannot be changed. Fixed resistors are used in circuits to limit current and produce a specific amount of it. So this will be the correct answer, resistor. We'll proceed with the next question. The element of an electric heater is made up of. The element of an electric heater is made up of. Options are given: nichrome, tungsten, platinum, and aluminium. So what will be the correct answer? The element of an electric heater is made up of. The element of an electric heater is made up of. The correct answer will be what? The correct answer will be nichrome. Why nichrome? It is because the element of an electric heater is typically made of nichrome, which is an alloy of nickel and chromium. It is preferred because of the following reasons. It has high resistance. Nichrome has a high resistance, meaning it resists the flow of electric current, causing it to heat up when current passes through it. It has high melting point, allowing it to withstand high temperatures generated in electric heaters without melting or breaking down. It is also oxidation resistance. Nichrome forms a protective layer of chromium oxide when heated, which prevents further oxidation and corrosion, thus increasing its durability. Tungsten, on the other hand, has a very high melting point. It is more commonly used in what? Light bulb filaments rather than heaters because it oxidizes quickly at high temperatures in air, requiring vacuum or inert gas environment. On the other hand, platinum has a good electrical conductivity and resistance to corrosion, but it is too expensive for general use in electric heaters. Aluminium is a good conductor of electricity and heat, but it has a low resistance, which means it doesn't heat up enough when current flows through it, making it unsuitable for the user in heating elements. So the correct option will be what? Our correct option will be nichrome. So we'll proceed with the next question. The next question is what? The next question is the first electric generator was built by. The first electric generator was built by Galileo, B. Isaac Newton, C. This will be C. Michael Faraday, D. Benjamin Franklin. So we all know Benjamin Franklin is not associated with this, Galileo is also not associated with this, and Isaac Newton is also not associated with this. So the correct answer will be what? The first electric generator was built by Michael Faraday. Dear students, we'll proceed with the next question. Hope you are getting all these MCQs. These questions will be useful for examinations. You can note it down. We'll proceed with the next question. The next question is what? Silicon is an example of. Silicon, we all know. Silicon is what? Silicon is a semiconductor because its conductive properties lie between insulators and conductors. Okay. So silicon is an example of what? Silicon is an example of semiconductor. We'll proceed with the next question. The next question is this will be when, okay? When we use large transformers, sometimes they become very hot. The heating of the transformer is due to. So the heating of the transformer is due to number A, intense sunlight at noon, number B, the heating effect of current, number C, hysteresis loss, number D, both B and E. You see here, large transformers, what happens? Large transformers heat up due to both the heating effect of current and hysteresis losses. When current flows through the transformer's coils, it generates resistive heat. Okay, this effect is negligible at low ends but becomes more significant as the load increases. Hysteresis loss is what? When the magnetic field in the transformer's core reverses, a small amount of heat is lost. This happens because the state of a system depends on its history, and the magnetic field path changes can affect the magnet's possible magnetic moments. So the correct option will be what? The correct option will be the heating effect of current and hysteresis losses. So this both B and C will be the correct option. The answer will be both B and E. So both B and C. This will be C. We'll proceed with the next question. The next question is, which of the following represents? See here, which of the following represents voltage? Options are given to you: work done into charge, B, work done into time divided by current, C, work done into charge into time, D, work done divided by current into time. We all know that voltage is what? Voltage is W by Q, is not it? Voltage is W by Q, and we all know that I is equal to what? I is equal to Q by T. I is what? Charge per unit time, is not it? So from here, if you find out Q, then Q will be what? I into T, is not it? So so this will be what? V will be what? V is voltage. So voltage will be what? W by Q. So W divided by, in place of Q we can put I into T. Okay. So we'll put here I into T. So what is I into T? I is what? I is current and T is time. So and W is what? Work done. So what will be the correct answer? The correct answer will be work done divided by current into time. So which of the following represents voltage? The correct option will be what? Work done divided by current into time. So we'll proceed with the next question now. The next question, this question is also very important. It is always coming in examination. It has come in HSLC 2020. So which of the following terms does not represent electric power in a circuit? So options are given to you: IR square, I square R, V square divided by R, and VI. So first of all, we will try to understand electrical energy. So what is electrical energy? Electrical energy is given. Electrical energy formula is what? P. Electrical energy means power. Power is defined as V into I. That means voltage into current. Okay. So which of the following terms does not represent electric power? Here the question is does not represent electric power. These terms represent electric power. So V into I represents simply electric power. So this will not be the answer. Okay. Question number option 4 will not be the answer because it is told here does not represent. Okay. So since P is power is V into I. So this will be the V into I will be will represent electrical power. Next, we know that as per Ohm's law, we know that V is equal to IR, is not it? V is equal to what? IR. Here R is resistance. So V is inversely proportional to current is inversely a constant voltage current. If voltage is constant, current is inversely proportional to resistance. So in place of V we can put here IR into I, is not it? So it will become what? I square R. It will become I square R. So this term will also represent power. In an electric circuit, this term will also represent power. So this will not be the option. Okay. Next, number 3, you see V square divided by I. We know that from here we can find out what? We can find out from here we can find out R. From here we can find out R. So R will be what? R will be V by I, is not it? R will be V by I. So V is equal to what? IR. Sorry. From here we can find out I. I will be equal to what? I will be equal to V by R. Okay. See here, from here we are finding out I. Look this derivation. From here I will be equal to what? V by R. So here we will put, in place of V we will put what? In place of I, sorry, not in place of V. V into okay, in place of I we will put what? In place of I we will put V by R. Okay. So this will be what? V square by R. It will become V square by R. So this will also represent electrical power in a circuit. So this will also not be the correct answer. So the correct answer will be what? Which of the following terms does not represent electric power in a circuit? The correct option will be what? IR square. So this question has come in HSLC 2020. Previous MCQs, just now what I have discussed, previous MCQs, these questions are also important. Okay. Students are advised to go through these questions, note it down, and revise for the examination. We'll proceed to next question. Yes, students. The next question is what? Choose the correct answer from the following. SI unit of electrical energy is A, watt, B, watt into second, C kilowatt divided by hour, number D kilojoule into second. So we all know that um, the typical unit of electrical energy is what? Watt into second. Okay, kilowatt hour is used for commercial unit, and typical unit is used what? Watt into second. So what will be the correct answer? The SI unit of electrical energy, the correct answer will be what? Watt into second. Let us proceed with the next question, dear students. The next question is what? The next question is the SI unit of electric field intensity and capacitor are respectively. The SI unit of electric field intensity and capacitor respectively. We all know that the SI unit for electric field intensity is what? Newtons per coulomb. Okay, newtons per coulomb. But what about capacitor? The SI unit for capacitor is farad. And what is farad? Capacitance is actually what? It is the ratio of the charge held in a capacitor's conductors to the potential difference between them. So it will be what? It will be coulomb divided by volt. Okay, it will be coulomb divided by volt. So your correct option will be what? Correct option will be number A, Newton per coulomb, and number A, Newton per coulomb, and coulomb divided by volt. The SI unit of electric field intensity and capacitor, Newton per coulomb and coulomb per volt. So option A is correct. Let us proceed with the next question. Electric potential is a vector quantity, a scalar quantity, neither is scalar nor a vector, sometimes is scalar and sometimes vector. So electric potential is what? What will be the answer, dear students? Electric potential is a scalar quantity. Why? Because it has only magnitude and no direction. It is defined as what? It is defined as the amount of work required to move a charge from one point to another without acceleration. Okay, so here the correct option will be what? Electric potential is always a scalar quantity. Let us proceed with the next question. The electric current depends on. This is a very important question, and students are advised to kindly understand this. The electric current depends on number A, capacitor, number B, field intensity, number C, potential difference, number D, electric field. You see here, the electric current depends primarily. Okay, the electric current depends primarily on potential difference, voltage and resistance according to Ohm's law. We all know that Ohm's law is what? Ohm's law is I is equal to V by R, is not it? Ohm's law is equal to I is V by R, because that means what? At constant voltage, if the voltage is constant, current is inversely proportional to resistance. If resistance is increased, current decreases. So potential difference directly affects the current. The higher the voltage across a conductor, the more current flows it, assuming constant resistance. The other options are not directly responsible for the flow of current. If you consider capacitor is what? Capacitor stores electric charge but doesn't define current directly. However, current can flow when a capacitor is charging or discharging. If we look at the field intensity, if you see the field intensity, then field intensity is what? Electric field and field intensity are related to forces on charges which can influence current in the presence of conductor, but they are not primarily determinants in a simple circuit. Okay, so electric field is also not the option, and field intensity will also not the option. The capacitor is also not an option. The electric current depends on potential difference. Okay, the higher the potential difference, that is the current. So we'll proceed with the next question. The next question is what? Which of the following device is used to measure potential difference? This question, I think students, you can answer it. Which of the following device is used to measure potential difference? So potential difference measuring device is what? It is always measured with the help of a voltmeter. This question was very easy, I think. It's not it, dear students. So let us proceed with the next question. The next question is what? 1 coulomb is equals to 10 to the power 9 nanocoulomb, 10 to the power minus 9 microcoulomb, 10 to the power minus 9 nanocoulomb. 1 coulomb is the amount of charge transported by an electric current from 1 ampere in 1 second. Okay, it is also equal to the charge of 6.241 into 10 to the power 18 protons. Okay, so here 1 coulomb is equals to what? The answer will be, correct answer will be what? 10 to the power 9 nanocoulombs. Okay, The correct answer will be what? 1 coulomb equals to 10 to the power 9 nanocoulomb. These two are not the correct options. The correct option is 1 coulomb is equals to 10 to the power 9 nanocoulomb. Let us proceed with the next question, dear students. Which of the following device is used to measure electric current? So our earlier question was which of the following device is used to detect current. If the question is to detect current, then you have to put the answer galvanometer. But in this case, which of the following device is used to measure the electric current? The correct answer will be what? Ammeter. Ammeter is a device which is used to read current or measure electric current. Let us proceed with the next question. The practical unit of electrical energy 1 kilowatt hour means. This question also came in HSLC 2019. 36 into 10 to the power 6 joule, 3.6 into 10 to the power 6 joule, 3.6 into 10 to the power 5 joule, 36 into 10 to the power 4 joule. So here the practical unit of electrical energy of 1 kilowatt hour means 3.6 into 10 to the power 6 joule. So this will be the correct option. Next, electrical resistivity of a given metallic wire depends upon its thickness, nature of the material, its shape, its length. As discussed earlier, dear students, I have already told you that resistivity is what? Resistivity is a characteristic property of the material itself, is not it? Electrical resistivity is a characteristic property of the material itself. It is defined as the electrical resistance of a conductor of unit cross-sectional area and unit length, okay, and is denoted by the symbol what? Denoted by the symbol rho. Here, 4 options are given. That electrical resistance of a given metallic wire depends upon its thickness, nature of the material, its shape, its length. Here always the option which is correct will be number B, the nature of the material. Okay. So electrical resistivity of a given wire always depends upon the nature of the material. Let us proceed with the next question. In a circuit, current becomes half when resistance is. So here this question is also very important, dear students. We will try to understand. Okay, as per Ohm's law we know that V is equal to what? IR, is not it? V is equal to IR. So if we see if the voltage is constant, as for example, if the voltage is constant, then we can write here that V by R is equal to what? I, is not it? Or I is equal to V by R. Okay. So if the voltage is constant, if you are keeping the voltage constant, then I is inversely proportional to resistance. Try to understand. If the voltage is constant, I is inversely proportional to resistance. Now if the resistance, here the question is what? In a circuit, current becomes half when resistance is. Okay. Now I is inversely proportional to resistance, or resistance is inversely proportional to I. Here I is current and R is resistance. So if current is half, current becomes half. Okay, if current becomes half, then what will be resistance? Resistance will be doubled. The correct answer will be what? Resistance will be doubled. Okay, so here in a circuit, current becomes half when the resistance is doubled. Always take the answer doubled. Thank you, dear students. Thank you very much. Thank you, dear students. Thank you very much. Hope you have liked my video, and this video has taken a little effort. I always appreciate my students who look my videos and share among their friends and peer groups. I personally request all of you to shower love and blessings on my channel. Making videos takes effort and time. I'm constantly working for students, and videos will be always provided in nearly regular basis. You can check my link description, so what I'm going to teach here. And hope, dear students, you are liking my videos, and please share among your friends, and do comment, do share, and do subscribe. Thank you. Have a nice day, dear students. Study well. Best wishes for your future. Thank you very much.